All right, let's talk about something we all use but probably never think twice about: bridges. I mean, they're these incredible monuments to engineering, right? Built to be super strong. But what if in our obsession with strength, we've kind of missed a huge opportunity to be a lot smarter?
Now, I know that sounds like a crazy question. We trust engineers to have this stuff figured out, of course. But what if there's a fundamental inefficiency, a sort of hidden flaw that's baked right into how we design bridges for our super crowded cities?
Well, just look at the traffic that's actually on our roads. Get this, about 90% of all the vehicles out there are just regular passenger cars, like yours and mine. Only a tiny fraction, just about 10%, are those heavy commercial trucks. But here's the kicker. Our entire design philosophy is dictated by that tiny, heavy minority.
Think about it like this. Imagine you're building a house, but you put in a foundation that's strong enough to hold up a 50-story skyscraper. It would be absurd, wouldn't it? A massive waste of concrete, steel, money, you name it. And yet, that's pretty much the logic we've been applying to our urban bridges. We build every single one to handle the absolute heaviest thing that could possibly drive over it, even if that heavy thing only shows up once in a blue moon. So let's break down the engineering a little bit. We're going to see how this whole design for the absolute worst-case scenario became the standard, and why, even though it's super safe, it might not be the smartest way to solve our traffic nightmares.
So here's the difference in black and white. Passenger cars, the 90%, they put a pressure or load of less than 5 kilopascals on the road. Let's just call that the baseline. But commercial vehicles? Whoa, they can exert 3 times that pressure, sometimes even more. That's the huge difference between a family sedan and a fully loaded semi-truck. And yet we designed the whole bridge, the deck, the piers, the foundation, everything, for that much, much heavier but way less common load.
And this quote from the source material just nails the core problem. The word they use is compulsion, and it's perfect. Engineers are trained, they're compelled, to design for the governing load. That's the heaviest thing that might cross. It's the standard, it's the default. But the question is, in a dense city, is it always the smartest default?
Okay, so this is where a really simple, almost obvious idea comes in and just changes the whole game. What if we just broke that compulsion? What if we designed a bridge specifically for the traffic that actually uses it 90% of the time?
And here it is, the Lightly Loaded Bridge, or LLB for short. Now, the definition here is absolutely key. This is not for every road, everywhere. It's a strategic tool. See, it's designed exclusively for light passenger vehicles, and it's only meant for dense cities where, and this part is crucial, an alternate route already exists for all those heavy trucks.
The game plan to actually make this happen is incredibly logical. Step 1, you find a city that's choked with traffic. Step 2, you confirm that the big rigs have another way to get where they're going. And then step 3, you build a new, lighter, way more efficient bridge to ease all that congestion for the 90% of us in our regular cars. Simple.
All right, now we get to the payoff. Why bother doing all this? Well, because the moment you free yourself from designing for the heaviest possible load, a whole world of benefits just opens up.
And this is where the dominoes just start to fall, one after another. A lighter load means less force on every single part of the bridge. The superstructure, the piers, even the foundations buried deep in the ground can all be less massive. That means you use less material, so it's cheaper and faster to build. But it doesn't stop there. With lighter cars, you don't need to account for as much braking force. This opens up totally new design possibilities, like sharper curves that can squeeze into tight city spaces where a normal bridge just couldn't go. You don't even need as much vertical headroom. It's this amazing cascade of efficiency, all from one simple change in thinking.
Okay, I know what you're thinking. This sounds great in theory, but what about emergencies, right? What happens when a fire truck or a heavy tow truck needs to get across? Well, don't worry. The people behind this idea have already thought that through.
First up, the fire engine. You're right, it's too heavy for a lightly loaded bridge. So if a car catches fire on the bridge, what happens? Well, just remember where these bridges are built. In dense urban areas. A fire truck doesn't need to drive onto the bridge. It can easily just pull up at ground level and access the fire from below. Problem solved.
And the exact same logic applies to clearing an accident. A heavy crane or tow truck can't drive on the LLB. But just like the fire department, it can be positioned right on the ground to reach up and clear a wreck. The solution is literally built right into the environment these bridges are designed for.
So when you put all of this together, you realize that lightly loaded bridge isn't just a new type of structure. It's really a whole new way of thinking about how we move through our cities. At the end of the day, just by challenging one single long-held assumption in engineering, we can unlock these massive benefits. We can ease the traffic that drives us all crazy, we can save a ton of money and resources, and we can just build the infrastructure of our future in a much, much smarter way.
And that's the thought I really want to leave you with. This isn't just about concrete and steel. It's about questioning the way things have always been done, and designing solutions that actually fit the world we live in now, not just the one we've always prepared for. It really makes you wonder, what else are we overbuilding without even realizing it?